When GPT-4 was released by OpenAI in CH 2023, it wasn't just another step forward in artificial intelligence, it was a leap. For those who had already been amazed by GPT-3 and GPT 3.5, the arrival of GPT-4 raised an obvious question. What makes GPT-4 different? To understand the evolution, let's first revisit the foundation. GPT, short for Generative Pre-trained Transformer, is a deep learning model that generates human-like text. It's trained on a massive dataset, absorbing patterns of language, grammar, knowledge, reasoning, and more. But with each version, the model's capabilities and its impact have grown dramatically. GPT-3, launched in 2020, had 175 billion parameters and introduced the world to language generation at an unprecedented scale. It could answer questions, write code, summarize articles, and even craft poetry. But GPT-3 wasn't perfect. It was known for making factual errors, lacking common sense in nuanced situations, and producing responses that could sometimes be inconsistent or biased. GPT 3.5, released in 2022, was a refinement of GPT-3. It improved the model's reasoning ability and made it more reliable in dialogue-based tasks. This was the version that powered the first iteration of ChatGPT, the viral chatbot launched by OpenAI. But even ChatGPT with GPT 3.5 had limitations. It struggled with complex reasoning, frequently hallucinated facts, and couldn't understand images. Enter GPT-4. The first and perhaps most important difference is multimodality. GPT-4 is not just a text-based model. It can process both text and images. This makes it one of the first major AI models to genuinely bridge the gap between vision and language in a single system. Imagine showing GPT-4 a photo of a refrigerator and asking what you can cook with the ingredients inside, or uploading a chart and asking for an explanation. With GPT-4, this becomes possible. Its ability to analyze visual inputs opens new doors in education, accessibility, and human-computer interaction. Another major upgrade is improved reasoning ability. GPT-4 performs significantly better on complex benchmarks. For example, it passed the Uniform Bar exam with a score in the top 10% of test takers, whereas GPT 3.5 scored in the bottom 10%. It also excels in STEM fields, including solving difficult math problems, programming tasks, and logic puzzles. This is thanks to improvements in the training data, model architecture, and fine-tuning techniques. GPT-4 is also more steerable. That means it can better adapt its personality and tone based on instructions. You can ask GPT-4 to behave like a Shakespearean poet, a software engineer, or a friendly assistant, and it will maintain that tone more reliably throughout the conversation. Under the hood, GPT-4 benefits from matchingly longer context length. It can handle up to 32,000 tokens, about 50 pages of text, compared to GPT 3.5's limit of 4,096 tokens. This allows GPT-4 to understand and generate much longer conversations, documents, and analyses without losing coherence. But it's not just about scale. GPT-4 has also been trained to be way safer and more aligned. Using reinforcement learning from human feedback, RLHF, OpenAI fine-tuned GPT-4 with human preferences in mind. The model is better at refusing inappropriate requests, less likely to produce harmful outputs, and more transparent about its limitations. This makes it more trustworthy in critical use cases like education, healthcare, and legal consultation. GPT-4 also introduces visual reasoning, which goes beyond just recognizing images. For instance, users can upload a meme, and GPT-4 can explain why it's funny. It can read diagrams, understand screenshots, and answer questions based on visual content, turning static images into interactive knowledge tools. Perhaps one of the most transformative differences is tool use. While GPT-4 itself is a language model, OpenAI enabled it to integrate with tools like web browsing, code execution, and file analysis in the ChatGPT product. This means GPT-4 can go beyond static knowledge, which is frozen at its training cutoff, and fetch real-time information from the internet, perform calculations, or even analyze uploaded documents and spreadsheets. This makes GPT-4 not just a conversational AI, but a true productivity assistant. GPT-4 is also more multilingual. It performs much better than GPT 3.5 across dozens of non-English languages, especially in translation, summarization, and comprehension. This is a significant step toward making AI more globally inclusive and usable across cultures and borders. Of course, GPT-4 isn't without limitations. Despite its advances, it can still hallucinate, producing text that sounds plausible but is incorrect. It doesn't have consciousness or self-awareness. It can't access real-time data unless connected to tools. And it's only as good as the prompts it's given. Prompt engineering still plays a critical role in unlocking its full potential. Still, the leap from GPT 3.5 to GPT-4 is one of refinement, expansion, and real-world usability. It's more capable, more reliable, more adaptable, and more versatile. It has already begun to reshape industries, whether it's helping doctors interpret medical reports, assisting students with research, generating code for developers, or providing mental wellness tools. The integration of GPT-4 into Microsoft products like Word, Excel, and Bing Chat has brought AI into the daily workflow of millions. And what makes GPT-4 different isn't just technical, it's philosophical. It represents a shift in how we relate to machines, not just as tools, but as collaborative partners. GPT-4 is part of a broader movement toward AI systems that understand, reason, and assist in increasingly human-like ways. So the next time you ask ChatGPT a question, draft an essay, or generate an image caption, you might be experiencing the subtle brilliance of GPT-4. It's not just a better model. It's a new chapter in how humans think, create, and interact with artificial intelligence. Let's dive even deeper into how GPT-4 changes the game by exploring how it's being used in the real world. In education, teachers are using GPT-4 to create lesson plans, grade assignments, and provide instant feedback to students. Its ability to generate detailed explanations and clarify complex topics while tailoring responses to different learning levels has made it a valuable teaching assistant. In law, GPT-4 has been tested for contract analysis, legal research, and even generating case summaries. While it's not a replacement for legal expertise, its ability to rapidly parse legal language and generate human-readable explanations saves professionals significant time. In healthcare, GPT-4's image processing capabilities open the door to analyzing X-rays, MRIs, and lab reports. Combined with its text comprehension, this allows for generating patient-friendly summaries of diagnoses, creating medical documentation, and even assisting with differential diagnosis under expert supervision. Another use case that sets GPT-4 apart is its role in assistive technologies. For people with visual impairments, GPT-4's multimodal capabilities can describe images, interpret screen content, and even help navigate digital interfaces. It's already being integrated into apps like Be My Eyes, where users can ask the AI to describe the world around them in real time. In content creation, GPT-4 is revolutionizing the way creators work. Writers use it to brainstorm storylines or structure outlines. YouTubers generate scripts. Designers generate captions and ad copy. The ability to generate coherent, engaging content across formats has made it a force multiplier for solo creators and small teams. In business, GPT-4 is powering chatbots that handle customer service with empathy and nuance. It's analyzing spreadsheets, summarizing meetings, and helping employees with day-to-day writing tasks. What makes this possible is the longer context length. GPT-4 remembers more of the conversation, making it more useful in sustained workflows. From a developer's standpoint, GPT-4 can write, debug, and explain code more effectively than any of its predecessors. It can simulate interviews, generate API documentation, and even refactor legacy code. Its understanding of logic, syntax, and programming language structure has surpassed many traditional search tools. And perhaps most exciting is its emergent behavior. Capabilities that weren't explicitly programmed, but arise from the scale and complexity of the model. For example, GPT-4 can solve puzzles, interpret nuanced jokes, and make sense of riddles. It can identify inconsistencies in arguments or summarize texts with embedded contradictions. These emergent abilities reflect a growing sophistication in how the model connects ideas and adapts to context. It's important to note that OpenAI hasn't revealed the full details of GPT-4's architecture, including its size or the precise data it was trained on. This decision was made, in part, for safety and competitive reasons. But what we do know is this: the improvements didn't come just from making the model larger, but from smarter training, better alignment, and strategic design. So to summarize, what makes GPT-4 different? It's multimodal, it sees as well as reads. It's more accurate, with stronger reasoning and fewer hallucinations. It's longer term, remembering and working across extended contexts. It's more steerable, adapting tone, personality, and style. It's safer, trained with human feedback for better alignment. It's global, performing better across multiple languages. It's tool integrated, browsing, coding, file analysis, and more. GPT-4 isn't just an upgrade, it's a shift in capability that redefines what we expect from AI. As we continue to build with and around GPT-4, it becomes clear